Question number 1 in paper 2 is fairly simple, where there is a rod which is hinged at the point O, and the rod is supported by a rope QP. There is an additional load of alpha W, which is kept at P. The problem is clear, the dimensions are clear. You can fairly quickly find out that this angle that the rope makes is 45 degrees. Why? Because the length of the rod is L, and also this distance Q to O is L. Very simple. Let's quickly draw the free body diagram of this rod. We would be drawing the free body diagram of the rod with respect to an inertial reference frame. The inertial reference frame is O. Okay, we will be calculating the moments with respect to O. Now, since it's a hinge point, we have to be careful of the reaction forces that are there at O. So what are the forces that are acting on the rod? The forces that are acting on the rod are its weight, W, which acts from the middle, this additional load, alpha W, the reaction forces. There are two reaction forces over here, one along the X direction, let's call it as NX, another in the vertical direction, let's call it as NY. There is also the tension acting at this point. The tension acts at an angle of 45 degrees. These are the forces that we require. These are the forces that we have. Quickly write down the three equations, the force equation along X, Y, and the moment equation. So along the X direction, I have Nx is equal to T cos 45 degrees. No other force along X direction. So this is T by root 2. What about along Ny? Along Ny or along Y direction, it's Ny plus T sine 45 degrees is equal to W plus alpha W. I can write it as alpha plus 1 into W. Let me name this as equation 1. Equation 2, I haven't completed. Let me simplify this a little bit. I can write Ny as equal to alpha plus 1 into W minus T by root 2. This is my equation 2. And next, let's draw the, we have drawn the free body diagram. Let's find out the moment equation. For the moment equation, we would be taking this point O as my axis. So about O, Nx and Ny doesn't have any moment. W has a moment in the clockwise sense. Alpha W also has a moment in the clockwise sense, and tension has a moment along the anti-clockwise sense. Let's take the clockwise sense as positive. In that case, I would have W into L by 2. W acts along this line, so W into L by 2 plus alpha W into L. That's all the moment in the clockwise sense. What about in the anti-clockwise sense? In the anti-clockwise sense, tension has two components. One along this line, which is T cos 45, another along this line, which is T sine 45. T cos 45 would not have any moment, only T sine 45 would have a moment. So T sine 45 degrees into L. So if you simplify this, see the L cancels out and you get alpha plus half into W equals to T by root 2. So I have three equations. Quickly, I need to find this out. See, from the third equation, directly I get T is equal to root 2 W into alpha plus half. So I have got a tension. Using this equation, I can find out what is the breaking point. The problem tells me that at 2 root 2 W, the rope breaks. Let's find out what's the value of alpha for that. So 2 root 2 W has to be equal to root 2 W into alpha plus half for the rope to break. So what do I have? W cancels out, root 2 cancels out, and I get alpha is equal to 1.5. So for a value of alpha greater than 1.5, the rope breaks. From here I get that option D is correct. What else? I have got tension over here. Let's find out what is Nx and what is Ny. Put the value of tension in equation 1. I get Nx is equal to, what is Nx? Nx is T by root 2. So Nx is W into alpha plus half. Hence, when alpha is equal to 0.5, Nx becomes equal to W. See, look at option B. Option B tells the same thing. That is, the horizontal component of reaction force at O is equal to W for alpha equals to 0.5. So option B is also correct. Let's get into finding out Ny as well. Put the value of tension in the equation of Ny. We have Ny equals to this equation, alpha plus 1 into W minus T by root 2. So alpha plus 1 into W minus T by root 2, which becomes minus W into alpha plus half. If you simplify this, what do you get? You get alpha W minus alpha W. That means it's simply W by 2. Observe, Ny does not depend on alpha. So option A is correct. I hope you got it. See, in this equation, alpha cancels out. You are only left with W by 2. So Ny does not depend on alpha. So option A is also correct. What about option C? So the value of tension we have got is equal to root 2W into alpha plus half. For a value of 0.5, when alpha is equal to 0.5, the value of tension becomes equal to root 2 times W. Okay, if you put alpha equals to 0.5, this part becomes equal to 1 and tension becomes equal to root 2W. But option C says that for this value of alpha equals to 0.5, tension is twice W, which is not correct. So option C is not correct. The final answers are option A, option B, and option D. These are the correct options. It was a very simple problem and can be solved very quickly.